In this video, you will learn about the statistical quality control processes, that what is statistical quality control and how we can calculate the control charts and what they tells us, and what is the difference between the basic charts and how many causes present in the quality control and how we can make our process in control. So I hope so this video will be useful for you to construct control charts and to make the process of any object, any new introduced item by using these tools. So if we say this diagram is well represented of the quality control, then this is 99% true. How? In this, you can say the stock control, quality control, and quality assurance. All these are basically total quality management preventions. So these three are interrelated. First, you have the quality, and then you want to assure it. Either it meets the quality management or not, either it is in control or not. What you have to do with this? So quality control, stock control, quality assurance. These three are the main terms in the total quality management. And you can say these are the preventions of quality management. So quality control is basically related with the quality assurance. So to assure the quality, we need the codes of practice, customer requirement, focus on groups, accessibility, regulation, compilation, external agency regulation, benchmark, and here you can see all these assurance will meet, then our process become in control. And we can say the quality control meet all the requirements of that term, which we need to improve the process or which we want to do for further study. So here are the approaches to strategic planning, in which you can say economic, imperative, political, quality, administrative. So this is clockwise related. And by using the statistical process control, we can improve the process and can describe our data well, can interpret our results like this is very common word, in God we trust, all others must bring data, but the statisticians create. So this is true to conclude or interpret your study or to give more reason, more fruitable conclusion and more reasonable results on the basis of control charts. So here are a few tips why use a control charts and what does a control charts do and which chart is appropriate to choose for which situation. So basically, charts and graphs are way of eye inspection, are visualization way, in which by seeing the chart, you can easily interpret the values. So to monitor, control, and improve process performance over time, you need some charts, and that charts which are constructed to check the quality of process, to monitor the observations, either they are performing well or there is some mistake or there is need to improvement of these, we need control charts. So control charts basically monitoring process variation over time and guides us how we can control them and at where or which points the process is out of control and we have to monitor that and revise that and make it in control by applying some tools. So it also helps us to improve the process, to perform the consistently about the quality assurance, and it also related with low cost and high effective results, and also can use everyone in his or her own new introduced item to check either that it passed the quality tool or not. Either it passed the quality management or not. Either it is in the process, it is live within the control tools or not. So here are a few tips how you can choose the control charts. So basically, there are so many types of control charts, and we mainly divide it into two: attribute and variable. So attribute further have so many categories, and variable charts also have different categories. So the important to note here is that which chart is appropriate for which kind of data set. So here is the rough rule of thumb. If we have the N1, then only the X and RM chart is possible to construct and give us more meaningful results. But when the observations lie between 2 to 9, then median and range chart both are good representative of the series of the data set of the observations of our new introduced item. And when n is small, like between 3 to 5, the best selected chart is the X bar and R. In this situation, when n lies between 3 to 5, mean and range charts give us much better result as compared to other chart. We can easily conclude these charts to draw a conclusion or interpretation about our series. But when n is large, in that case, we have to move a step up, like we need to identify the variation in that. So the best combination chart in that cases are mean and standard deviation. The mostly used chart in our routine data set are the mean and range chart, and they are very easy and simple to construct. And we can easily manage these charts, and by using these charts, we can identify and determine either the process is out of control or within the limits. If the process is within the limits, then we can conclude our data as it meets the quality management tools. So we can say this is the best. But if this is violate our live in out of control limits, then we need to check the reason. Either this is out of control due to which cause, and what are the reason behind that. We have to determine that reasons. So here are the discussion about some attribute chart. As whenever we talk about the attributes, it's mean that now we have qualities instead of quantities, and there is a big difference in quality and quantity. We cannot apply the same analysis for both. We have different kind of analysis. Like if we have the qualitative nature of the data set, we cannot find the mean. So mean is meaningless there. Why? Because we cannot add character in character. Like if we are talking about the eye color, we cannot add brown in black, in white. So we need some coding, we need some other tools which represents this quality well. Similarly, if we have defects, like we want to discuss about some political parties, in that case, we need proportions. Proportions are the best tool to interpret or conclude about political situations. Similarly, we have so many situations in which we need to choose different tools accordingly. But first, we must identify either the problem is related with the quality or with the quantity. So once you have cleared your line or dimension, after that, you have to move towards the appropriate tool. So if your data is qualitative, then you cannot choose these kind of charts. But if the data is qualitative, only then in case of variables, you can choose these charts and apply them easily. But if your study is related with qualitative factors, then you need to find defect or non-conformity data and defective data. So in this case, you have constant variable sample sizes, as C chart is the best representative for constant sample size. U chart for the variable sample size, but whenever your sample increases, like greater than 50, then for constant P, our NP chart, P is the proportion chart, and our NP chart, you can use both. And in case of variable, you need P chart. So here are the some charts, how some tips how you can construct control chart. So select the process to be charted. Either it is qualitative or the quantitative. Once you have determined the process nature, after that you have to decide the appropriate chart. So if it is related with the quantitative, you can easily choose mean chart, range chart, or if you have given some name of the chart for construction, you have to choose that chart. So here are the control chart construction that which you need to draw chart. So you have to choose first the name of the control chart. After that, you have to require the formula to calculate the limits of that chart. Once you have calculated the limits, now the next step you want to construct that limits. So to construct the control chart limits, you have to draw the line on the paper and roughly sketch there three control lines: central control limit, upper and lower control limit. You can take equal distance of upper and lower control limit. Once you draw the control limits, after that you have to sketch the remaining values on the plot and interpret it accordingly. Either your process is in control or out of control. It depends upon the nature of the problem, and then you can easily identify the causes. Now let us take a simple example to construct X bar and range chart. So here you can see some sample observations that are from 1 to 3, 11 to 20, 21 to 30. And here you can see the X bar values and R values. So what you have to do, you have to calculate the limits first to draw these charts. So when we construct the control limits, we need here n is the 5, means we have this X bar of 5 observation, this range for 5 observation, means each sample have 5 group of observations. So this is mean of 5 observation, this is the range of 5 observation. So each sample contains 5 size. So here n is 5. When we calculate the X double bar, that becomes this, R bar is this. We need the table values of A2, D3, D4 to construct the control limits and to calculate it. So when we calculate, the results becomes upper control limit is 60 for X bar and for range 39.4. Central limit is 49 for X bar and 18.6 for range. Lower control limit is 28.89 and for R is 0 because the D3 value is 0 in this, so we have 0. So we construct the this data and this result is the outcome of Minitab software. So here you can see the upper control limit is this, lower control limit is this, and here you constructed this central control limit and draw the all sample points 1 to 30 here. So the points which crosses these limits are known as out of control, and remaining process which lies within upper and lower control limits are considered as in control. Here you can see only one point indicates us that the process is out of control on the basis of X bar chart. So what we have to do, we have to check the second sample now and determine the reason or the cause. Either it is due to the assignable cause or the random cause. So if it is due to the assignable cause, we need to check it, revise it, and want to make it in control. And might be this is due to the quantity, and this can be on the fault of employee. This can be due to the electricity issue. This can be typos. So we need to determine this, the reason of this point, why this lies out of control or exist, not lie within control process. So when we construct the R chart in Minitab, our result is this. Here you can see all the points seems to be in control, and the reason is that uh, in rain chart we have few variation, few tools, or you can say the best suitable chart for this data set is the rain chart, as it gives you the more variation instead of X-bar chart, and you can see the pattern is more or less are the same. So by this you can easily construct X-bar and R chart. So there are two types of causes in quality control. One is the assignable cause and other is the random cause. So we have to need to determine this cause. If our process is out of control, then we have to check those points at which the process is out of control to identify the cause. So if it is due to the assignable cause, this can easily rectify and we can easily make the processes in control. So assignable cause basically is in our control, is in researcher's control, in which the researcher can do some processes, can apply some techniques to make it in control. So assignable cause basically is a major cause in quality control, due to which the mostly processes becomes out of control. So once we rectify cause, we can apply the quality control management tools to make it in process or to make it in control. But if the process is due to random cause, then we cannot do anything because this is inherent in the system. This is built in the process. And this cause is not in our control and not in researcher control. So researcher cannot do anything with the random variation or with the random cause. Let us take a simple example to understand the meaning of these two causes or how we can differentiate the random and assignable cause. Let us say we have a cold drink bottle. In each and every cold drink bottle, there is difference in few drops in their filling. Like not each and every cold drink have equal number of drops in bottle. So when you see the paper based on the bottle, it is also contain the quantity plus minus 0.25 milliliter. This is basically due to the random cause, which is built in, which is not in control. But if the cold drink bottle filled half, then there is need to identify the reason. There is need to determine the cause. What cause behind this half filling? Either the quantity finish at that time, or there is electricity issue when the bottle was filling. Either electricity make this filling half, or there is fault on the part of employer at that time, or there is any other reason of that half filling. So that half filling is the alarming situation, which is due to the assignable cause, and this cause is in our control, and we can revise the process, identify it, repeat the process at this point, and can make it in control. So this is the basic concept of random cause and assignable cause, where assignable cause is in our control, can be rectified, can be determined, can be fixed, and the process becomes in control. Whereas in random cause, we cannot do anything because this is inherent in the process, and this is the output of so many countless minor factors. So the researcher cannot do anything with it. So if the process is out of control due to assignable cause, it can easily rectify, it can easily make in control. But if the process is out of control due to random variation, then we cannot do anything to make it in control. So control charts help us to identify the points at which our process fail the quality limits, are at which we want to revise the process and want to improve the quality. And once we have determined that point, after that we have to rectify the exact cause. Once we rectify the reason of cause, then we can easily make it in control by applying statistical quality control process. So this is the basic concept of control charts, why we need it, because we want to check the process, and this is the easiest way to determine and identify the points where our process fall in control and where it lies out of control. So once you have determined that points, the next step is to rectify the reason. So there are two types of causes in quality control processes: random and assignable. So you have to determine the cause. Once you have determined the cause, then you have different tools to make it in control. So by applying that tools, you can easily revise the process of your series and make it in control. So this is the basic about the control charts and the causes.